Welcome back, space fans. Let's get right to it. So today we're going to talk about some in situ resource utilization. Now that we've got our base set up, we are going to process some resources. No alumina at this current location. I'm going to have to send vessels out to the hills up yonder to gather that alumina. But for here, we have a few things that we can process that I wanted to show you real quick. So first thing that we might want to do is get power going, because we've got the beamed power, lots and lots of beamed power, and that's great. But every now and then that transmitter goes out of range, and that causes us problems, because we've got, like cryostats and stuff like that we got to keep powered. So we want to get our fusion reactor right here going. So we've got ourselves a tri-alpha colliding beam fusion reactor. It's super duper awesome, and I've opted for the proton boron 11 fusion. And let me show you why. Right now we've got 40 grams of boron. Where did we get that? Well, what we did here is we turned on our drill, and if you look at our mining interface, if you see right here borate, 5.9%, so almost 6% abundance for borate. So we're producing, 0.01 tons per hour. So not the hugest amount, but a decent amount. We've got half a ton of borate stored, and we can store 1.5 tons. So we can we can store a lot. All right, so all that borate goes right here. That's carbon. That's where the carbon goes. Let me zip around here. It's right there. Yeah, all that borate goes into this container. It's just a hex segment cargo container. Looks very much like this one, only it's on this side and in the dark. Okay. All right. Next to that, we've got boron. Okay. So you take your borate, that's the ore, and you process it into boron. Okay, and I just did a little test run real quick here just because, but use your all-in-one refinery or the appropriate processor there for that, and you look for start borate processing, and it's pretty simple. You just click it and it starts. The materials that you're going to get from this, if we go to our list, move these out the way, while you're doing this, you're going to be getting liquid oxygen, okay, and you're going to be getting boron. Okay, so it's going to be like some sort of boron oxide, oxidate or something like that. So you're just separating out oxygen from the boron. So you sequester your boron here. We've already got 1 unit, so we're collecting that pretty swiftly, and then we're taking the oxygen and liquefying it so that we have liquid oxygen. Okay, so it looks like it's coming off as gas, and then we're liquefying it. So you're going to have storage for gaseous and liquid oxygen if you want to go that route. Anyway, so what do we do with the boron once we get it? There's carbon again, boron. So we've got a few kilograms so far. We've got 10 kilograms of boron. So it's just going to keep filling up. What can we do with 10 kilograms of boron? Well, if we look at our reactor control window, we're all the way up to 13 kilograms. So it's going quickly. We've got plenty of power to jumpstart the reactor from our beamed power network. It's good to have those in range. So really, I guess I already started this one, didn't I? Yeah, you just start it, as long as you get enough beamed power, and then it can do that. So let's go ahead and turn our receivers off. Disable. There's a bunch of these. I should have put a hotkey to it. Disable. Disable, and there we go. All right, the top one, number 4, that one, disable. Okay, so everything's disabled. We have no power generation, so let's go ahead and turn the generator on. Activate. There we are. Alright, so we power up right away, and once this settles, we'll take a look here. But you can already see we've got about 30 years worth of boron at 2% power, supplying about 6 megawatts. We get, and it's still climbing as it reaches thermal equilibrium. 34 years, 35, and we're also continuing to climb, so we're up to about 40 kilograms of boron. So it looks like you get, for every kilogram of boron, you get just over a year of use at the 6 megawatt range. Now it says its current maintenance is 14 megawatts. Now that doesn't seem right. Tri-alpha is only consuming 284 kilowatts to maintain fusion. I guess that's maximum is 14. Right. Okay. So anyway, once you've gotten yourself just a teeny tiny little bit of boron, as you can see, that took us all of a minute to produce. You could stop right there, you know, and your reactor will comfortably hang on to that for about 40 years, just running basic operations, nothing even fancy. But you could turn all your stuff on and see how far you get with that. So let's turn on our basic things. I have an excessive amount of ore harvesting because the smelter actually requires a lot of fuel to run. So so I keep the refineries going pretty much constantly. Let's spool up right there, and then start converting the metal. Now, as this goes, as we've mentioned previously, we collect hydrogen, which is used by all sorts of things. So as this smelter runs, we're collecting hydrogen. We're producing more hydrogen than we're using in the fusion reactor to run all the electricities. The smelter, of course, is using liquid fuel and oxidizer. It's the only thing I really use liquid fuel and oxidizer for in my games, is the smelting. So that, and this craft has a liquid fuel oxidizer landing assist and a fuel cell, which we're going to turn off. Since it's connected to this whole thing, I figure it's safe to use that since I'm already harvesting it. It makes sense. Like, I've already got it. You can run this fusion reactor in many other modes, depending on what you have available. So, like, if you only had lithium available, you could do some, like, deuterium. If you had deuterium and lithium available, it would be really good. But right now, we're just going to use proton-boron fusion because there's plenty of boron, there's plenty of hydrogen, and literally the act of running the reactor to run the drills in the refinery replenishes the reactor fuel with goo more to spare. Yay. Okay, so that's borate. Okay, borate to boron to fusion reactor. Cool, right? Rightio. So that was Z. Now let's look at something else. In the process of running our reactor, we are producing helium. The proton-boron fusion is going to produce a helium-4 byproduct. Okay, so we're storing up all that helium. Now, what can you do with that helium? Well, one thing you can do, and by the way, if you don't have your own helium, or if you don't, well, anyway, one thing you can do with the helium is you can turn it into carbon. Okay. So you look over here at your cyclotron particle accelerator. You open up your reactor window. You got lots and lots of fusion modes. And different ones will show up depending on what inputs you have. So if you have this thing and you click on it and it's like, it's not showing you any other fusion modes, it's because you don't actually have the materials necessary in order for that fusion mode to run. So that's just one of those things. So as you have the right materials on board, and as the thing unlocks, you'll be able to unlock more and more fusion modes. So if you have it, helium will produce carbon. If you fuse those together, you'll get yourself a nice little carbon atom. We are also, of course, getting carbon from our smelter. But if you don't have the smelter and you still want to do that, you get your helium and you fuse it together as carbon. Okay? Cool, right? It takes about 5 megawatts of power because I have this thing scaled down really small, and it doesn't produce very much. Carbon production is about 180 milligrams per hour, which is still respectable. But yeah, you make your carbon, right? And it just fills up. Not a whole lot. 50.67 units of carbon is about 106.5 kilograms of carbon. So not very much. Once you've got enough carbon, though, you deactivate that, and you're like, all right, well, what do you do with that carbon? Isn't it just soot? No. You turn it into oxygen. You've already got all that helium, right, that you were using to make the carbon. Well, you take some more of that helium, and you fuse it with the carbon that you just made, and you make oxygen. activate, and suddenly you're producing 360 milligrams of oxygen per hour, which your Kerbals will be happy about because they like to breathe that stuff. And you can also use it for other industrial processes. But that's how you go from your borate to the boron to the tri-alpha to the helium to the centrifuge, and then you make carbon. And then you take that carbon and you turn it into oxygen. Basically, you are mimicking a star, only you're on a comet. You're digging up a comet and turning it into oxygen so that you can breathe. Cool, right? Okay, really quick. If you have enough electricity available, if you have enough megawatts, a lot, like 500, and you have some hydrogen, and you want some antimatter, like antiprotons and positrons, one thing you can do is use that cyclotron of yours, cyclotron particle accelerator, and a little bit of beamed power. Let's turn on our receiver, make sure we got lots, and then we just turn that on, right? And it will go ahead and use that hydrogen and turn it into antimatter in decent amounts. Now, I don't have any storage, so this is all wasted electricity, so we're not going to actually do that. But I did want to show you really quick that particle accelerator that I've got going on right here, this thing right there. Now, it is tucked inside of this this control unit right here, but it's basically right there. It's right there, inside of there, and the people inside work on it. If you got one of those, you can make antiprotons as well. Likewise, you can use those same protons, the hydrogen, and just smash them together and produce some deuterium for all of your needs. Be sure to have storage for gaseous and liquid deuterium so that you can catch the particles and then liquefy them. If you don't have the appropriate storage, you won't actually be able to collect these. Now let me show you what happens. I guess I don't have the right one. My deuterium storage, I do believe, is only gas. Yeah. Okay. So gas for your deuterium, apparently. I thought I had liquid storage for deuterium on here, but it's probably around here somewhere. I'll find it later. Anyway, make sure you got your gaseous storage for deuterium so that you can store up on that. We got about 1 milligram going here, and again, we're just using that hydrogen to do that. Okay, let's go ahead and turn that one off. And then once you've collected enough deuterium, you can use that same stuff to fuse it into helium-3. So protons, hydrogen, and then deuterium, also hydrogen, but with that extra neutron, and you smash it and you get helium-3. So if we activate that, and boom, we are producing helium-3 at the rate of 360 milligrams per hour. Pretty cool, right? Once we run out of all that deuterium, though, we'll have to make some more in order to make more helium-3. But we're basically just going to convert all of that. Well, not really. I'm just going to turn this off. But we've already got 1.3 milligrams of helium-3 stored. And of course, your tri-alpha fusion reactor. Whoops. Probably shouldn't have done that. I don't know where that was. Will happily use all manner of different modes to do that. It's not going to switch right now because it's like the only thing powering everything. So it's like, no, I'm not going to turn off. Safety features. All right, so that's enough of that. All right, let's get to the fun stuff. Okay, Regolith. Regolith is fun stuff. All right, so if you look over here at your readouts here, at this particular location, I have 7.37% abundance of Regolith. That's a lot. I am scooping up just bunches and bunches and bunches, and I can store bunches and bunches of bunches. All right, so all of our regolith doesn't go there; it actually goes here. So far, we've got 738 kilograms of regolith. Cool. What do we do with it? I don't know. All right, so let's go over here and we look at Start Regolith Processing, which it's actually, I'm sorry, I apologize. You open your refinery window, and it's Regolith Processing is located inside of here. Regolith Process. There we go. Enable overflow, and I'll move this to a, whoops. Go ahead and move that out of the way. And then if you can see here, about 20 megawatts of power, which we have, and it is scooping up all sorts of things. Except liquid water. Wonder why that is. Maybe I need to liquefy my water? No. Ah, there we are. Interesting. Okay, so not quite all the way down, but now we are producing everything except carbon monoxide, but I'm getting plenty of that anyway because I'm already producing it. Alright, so hydrogen, deuterium, helium-3, regular helium, carbon monoxide and dioxide, methane, nitrogen, liquid water, all of these things out of our regolith process. Okay? Just oodles and oodles of materials from processing regolith. You can see over here we're just filling up on all sorts of materials across the board that we can use. Obviously, these are all extremely valuable materials. Nitrogen, incidentally, is really good because we don't have any nitratine here, and we're going to want ammonia because we got plants. We want ammonia. We don't have any ammonia yet, and it's also good for industrial applications. So we're just going to go ahead and store up as much of this stuff as we can, and yeah, go ahead and I think I'm going to start liquefying the nitrogen just to make sure. There we go. Liquid nitrogen is filling up. There we are. Okay, so let that run for a while, and then you've got your nitrogen and your hydrogen, which you can then put into the Haber process. Let's go ahead and take a look at that real quick. Turn that off. And also, it's a good idea to have more than one refinery or ISRU unit. Like you can have the main one and then like a bunch of the hex cores or the specialized ones. That way you don't have to turn one off in order to start a different process. But if we go to Haber process, okay, if we go to the Haber process, H2 plus N2 is going to give us NH3. So if we turn that on, it says missing nitrogen. That's right, I wasn't supposed to liquefy it. My bad. My bad. Okay. Turn a little bit of that into gas. We probably need a little bit of gaseous hydrogen. There we go. Alright, so ammonia right there. And there we go. Make sure you got your gaseous hydrogen and gaseous nitrogen because the Haber process is a gaseous process. It's using, I think here on Earth we use like catalysts, like metal catalysts, like I think a platinum catalyst or something like that. But here we're just, I don't know what they got in there. Probably dug it up from Memnis. But yeah, you smash your hydrogen and your nitrogen into ammonia, and then you store that. Good stuff. Okay, now if you can make ammonia, you've probably got something nearby where you can make methane, and that seems kind of counterintuitive, right? Methane is carbon and hydrogen, and ammonia is, of course, nitrogen and hydrogen. Well, really all you need is the hydrogen, because carbon and nitrogen are actually everywhere. As you saw, they are some of the first things produced inside of a star. So you're going to find those things in different forms wherever you go. It may not be in quote-unquote organic compound, as in a living creature, but it's going to be some sort of compound with carbon in it because it came from something that blew up inside a star. Yeah. Anyway, so you take, the regolith process, amongst other things, produces methane when you're running that. So obviously, all you'd have to do is just run the regolith process, and you can collect your methane. Or you've got your drills going here and your ore smelter here, and this thing is producing carbon, carbon dioxide, things of that nature. So you store up your carbon dioxide and put it somewhere like that's carbon monoxide. Well, the carbon monoxide, actually, we could just use that. Let's use carbon monoxide. So we go to our refinery and we turn this off. And then we're going to take the water that we got and we're going to do a water gas shift. Okay? H2O plus CO is going to give us CO2 and H2. Okay? Where do we get the water from? Well, the smelting process produces water. There's water in the ground. Water came from a number of sources. I think you get water out of the regolith process. Let me check. Yeah, you get water out of the regolith process. So water we've got plenty of, because we're on a comet. So water gas shift, and it will slowly, you know, produce hydrogen, and it will produce carbon dioxide. Okay, cool stuff. Now, once you've got your carbon dioxide, okay, you go up here to your, oh, where is it? Sabatier process. Okay, this is something used in a lot of life support mods, where they're basically scrubbing your CO2, and it produces something that they call waste. Well, that waste essentially is methane. So you take your CO2 and your H2. Remember, we got some of that H2 off of the process we just did. Literally, the water gas shift gave us CO2 and H2. We take those exact same processes or components, put them in the Sabatier process, and out comes oxygen and methane. Okay? So we smelt some more, and we take those byproducts, we run some water over them, and then we heat them, and then we get oxygen and methane. Heat them over a catalyst, of course. And you slowly fill up on that. And you can put your methane... Where did I put my methane? It's over here somewhere. Ammonia, peroxide, there's water. I have so many tanks on this thing, I don't know where anything is. I don't know. There's methane on this thing somewhere. I'm sure of it. There it is. Liquid methane. Goes right there. So let's go ahead and liquefy some of that stuff. And there we go. We have ourselves a few kilograms of liquid methane. About 7 or 8 or 9, 8.8 kilograms of liquid methane is what we produce from those few reactions that we just did. Scale that up, and you got lots and lots of methane. It's like 20 units, but you're going to want more to launch your rocket. Okay. Did we make ammonia already? I believe we did, yeah. So you make your ammonia, and you can do that stuff, and then you can take your ammonia and your peroxide, and you can make hydrazine. Oh yeah, we didn't make peroxide, I'm sorry. So to make your peroxide, you just take your hydrogen and your oxygen, and you put them together and you make peroxide. Okay? Now, if you want to make hydrazine, so you know, after you've made your peroxide, you just make however much you think you're going to need. That's a great fuel by itself, so I mean, you don't really have to go farther than that. But you take your hydrogen peroxide, or HTP, high test peroxide, not the stuff you buy in the grocery store. This stuff is, like, the stuff you buy in the grocery store is diluted. It's mostly water with some peroxide in it. This is high test peroxide. This stuff will eat your arm off. It'll oxidize the snot out of you, literally. So you mix that stuff with the ammonia that will also eat your arm off if you have it concentrated enough, and you produce hydrazine and some water. So you get some of your water back, and you know, water's not really a problem because I mean we're full up on it. We can't actually hold any more liquid water at the moment. So you know, but yeah, you know, just peroxide, ammonia, and then you make hydrazine. Lickety split, easy stuff. You know, CO to CO2, and then you know, so you can, if you want, you can convert the CO2 back to CO, or you can convert that CO2 and the hydrogen to methane. So you got all sorts of options for fueling your craft. You know, peroxide, ammonia, hydrazine, methane, liquid hydrogen, CO2, like this one is. This one's powered on CO2, it just shoots it right out. So all sorts of fuel options right here, and you know, I haven't even scratched the surface, so to speak. Can't do any atmospheric extraction here, obviously, because there's no atmosphere. But if this were on a flat spot on a planet with an atmosphere, you know, incidentally, I wouldn't really recommend something like this on a like on Duna, as this will crumble and bump around, and like Duna doesn't have flat spots. So you know, like even with Minmus, you know, it's flat, but there's like a 0.03% you know, grade or something like that. It slopes ever so slightly. So you know, 2 kilometers out is the horizon. You know, that horizon, as we saw earlier, is 2 kilometers out, not, you know, 2,000 kilometers. I said like 1,800 kilometers. I meant 1,800 meters is how far out that horizon is. So there's a slight slope. So the thing, I put it on the equator so that it would flop, so to speak, ever so gently on that 0.03% grade, right along, like from the equator out. So it's like a gentle, gentle slope. Doesn't even notice. It doesn't budge, doesn't shake. It's great. So yeah. Okay, so we covered those. What do we have next? Let's take a look at our drill. Substrate, uraninite. Oh yeah, so uraninite, I don't have any fluorine, so I can store uraninite, sure, and I can even process it. Like I've got uraninite processing going right here. So it's storing it as one of these. Let's see, there's some depleted uranium. Where's the enriched uranium? I know it's in one of these. I have a little bit of enriched uranium here, but it doesn't appear as though I have storage for everything that I needed. I'm going to switch this one. Enriched uranium. There we go. Okay, so I'll start storing some of that in here instead of in there, because that might be a little weird. But yeah, I can't do anything with the enriched uranium at the moment. I mean, there are a couple of reactors that'll run on it and a couple of rocket engines, so I can use it for those, so it's not completely useless. But until I get some fluorine flown in, I can't really do anything else with that. Incidentally, I can recycle the depleted uranium, but since I have BD Armory and K-Tech, I kind of changed some of the ammunition builds around to require depleted uranium to make some of the advanced rounds, like railgun rounds and stuff like that. So I'm going to use this for fun stuff too, just because. All right, finally on our list for this episode is